Hello, welcome to this overview of containment and surveillance for nuclear safeguards. Let's begin by explaining what we mean by containment and surveillance. Containment describes techniques that limit or detect access to an item or group of items. This is things like containers, tamper-indicating devices, and tamper-indicating enclosures. Surveillance describes techniques that provide continuous monitoring of an item or process to detect unauthorized access or activity. Cameras are the most common method of implementing surveillance, but other attributes could also be monitored via surveillance. Things like radiation, weight, heat, etc. Containment and surveillance, along with nuclear material accountancy, support something we call continuity of knowledge. We define continuity of knowledge as a system of data or information for an item or activity that is uninterrupted and authentic, and which provides adequate insight to support safeguards conclusions. Continuity of knowledge is really about having an uninterrupted knowledge of an item or process so that we know everything that has happened to it from some previous verification to the present. This gives us a high level of confidence that nothing has changed without detection. Next, we will talk more about containment techniques. Containment techniques include tamper indication and detection using a combination of tamper-indicating devices, often called seals, along with containers, overpacks, rooms, and other enclosures used to detect unauthorized access to materials or equipment. Containment techniques must provide evidence of unauthorized access or entry. So, what is a tamper-indicating device? A tamper-indicating device, or TID, is a device designed to leave non-erasable, unambiguous evidence of access or entry. TIDs are often referred to as seals because they seal a container against undetected opening. Unlike locks, seals are not necessarily meant to resist access, just record that it happened. We use TIDs because it is impractical to measure all items for each physical inventory due to things like radiation exposure, time required, or simply the cost. TID and container integrity assure an item is unaltered and confirm the previously measured value still has validity. TIDs are also used to detect attempts at tampering with material control and accounting, and/or security equipment and systems. TIDs are commonly used on containers of special nuclear material in long-term storage, for off-site shipment, on waste containers, and for transfers between material balance areas. They may also be used for areas where radiation exposure precludes regular material access or prevents easy measurements of material. TIDs are also used for any area or equipment where unauthorized access would impact MC&A. A TID program is not expected to provide initiation of timely security response or protect against overt action. A TID program is meant to detect covert or insider actions, particularly where those actions may be protracted over a period of time. TID use requires a carefully planned and implemented program to be effective. Indiscriminate and uncontrolled use of TIDs may have a negative impact on safeguards and operational effectiveness by providing a false sense of security. TIDs are almost always used in connection with other safeguards measures. Let's talk about some terminology that is used with TIDs. Adversary is the term used to describe any person or group of people who would attempt to gain unauthorized access to a protected asset. Any attempt the adversary makes to defeat a security measure is called an attack. An adversary who has official access to information, operations, or materials, most likely because they work at the facility, we call an insider. Another term often used is anomaly. An anomaly is any condition of a TID, item, or program record that requires an investigation or other response. Anomalies include missing, violated, or damaged TIDs, but also identifier discrepancies, cases where TID numbers don't match the records, improperly applied TIDs, unauthorized use of TIDs, uncontrolled records, and signs of tampering. An anomaly may indicate an attack, but could also be the result of accidents or careless mistakes. There are two main characteristics of a TID, the integrity and the identity. The The integrity is the ability of the TID to indicate that an attack has occurred. This would include things like the seal body and attachment mechanism that prevent it from being removed without damage. The identity is the ability of the seal to be differentiated from TIDs that otherwise appear identical. This might include features like a serial number, barcode, inspector's signature, or some unique random pattern. The identity is the characteristic of the TID that prevents an adversary from applying a new one in place of a tampered one without being detected. There are two primary categories of TIDs, active and passive. Passive TIDs require physical inspection to determine containment. Typically, they have no electronics and rely on physical or chemical mechanisms for integrity and identity. Active TIDs provide continuous monitoring of containment. This allows them to record a date and time of application and opening. They require some embedded electronics for monitoring and are often battery powered. They may have the capability to be monitored remotely using a wired or wireless connection. TIDs have four main attachment types: loop or cable, bolt, adhesive, and shrink wrap. Each attachment type has its own strengths and weaknesses. Often, the attachment type must be selected based on the restraints of the container it is to be used on. Tag is another term that is often associated with TIDs. We use the term tag to describe a unique identifier or intrinsic feature that can be used for asset identification. A tag has the identity characteristic of a TID, but may not have the integrity characteristic. A TID can always be used as a tag because it has the identity characteristic, but a tag may not be usable as a TID. Finally, a TID requires a use protocol. The use protocol is the set of procedures for use of the TID in a specific application, including procedures for attachment, verification, removal, and destruction. So, we have covered tamper-indicating devices, but there are also other forms of tamper indication required to make containment work. Consider the case of a drum of special nuclear material secured with a TID. The TID secures the opening of the container only. If the drum is damaged or cut in another area, material can still be removed without violating the TID. In this case, the drum is an integral part of the containment. A tamper-indicating enclosure, or TIE, is a special kind of container or enclosure designed specifically for tamper indication. In summary, it is the combination of a TID and container integrity that provide containment. This provides evidence that the item is unaltered and the previous measured value still has validity. This helps to reduce the time, cost, and potential safety consequences when conducting physical inventory. Tamper-indicating devices and enclosures are used to detect tampering with safeguards equipment. Containment via tamper indication is one part of containment and surveillance, which supports continuity of knowledge for safeguarded items. What is surveillance and why is it used? Surveillance describes the continuous monitoring of an item's presence or absence through some attribute. An unattended monitoring system, sometimes called a UMS, is a surveillance system designed to operate between inspector visits and provide continuity of knowledge for an item or process. Most surveillance systems operate in this mode. Though this definition includes a camera system, the term UMS is commonly used for non-camera unattended surveillance systems. A surveillance system might consist of one or more sensors for item or process monitoring, including cameras and/or other attribute sensors like radiation monitoring. Surveillance is used primarily to supplement or replace physical inventory and/or containment techniques. This is particularly useful when material access is limited, physical inventory is costly, or continuous monitoring is needed. Let's talk about some terminology that is used with surveillance. Authentication is the act of establishing or confirming something or someone as authentic by establishing its identity or origin as genuine. Authentication is the process by which we establish the source of surveillance data is genuine and that it can be trusted. This prevents an adversary from spoofing the data. Encryption is the process used to make data unreadable to anyone except those possessing the key. This prevents third parties from monitoring the data without approval. Encryption and authentication use some similar cryptographic techniques, and so are often addressed together, but they are distinct concepts that can be applied individually. Before a new surveillance system can go into use, or an existing surveillance system is placed in a new application, a threat assessment and vulnerability assessment must be completed. A threat assessment involves a thorough analysis of the credible threats to a safeguards or security system. The threat assessment forms the basis of a vulnerability assessment, which is an independent analysis of a safeguards or security system for potential weaknesses that an adversary, identified during the threat assessment, could exploit. Sometimes these assessments include two teams. A red team tries to attack the system to identify weaknesses or vulnerabilities, and a blue team works to thwart the attackers and potential adversaries. There are a variety of types of surveillance systems. Cameras are by far the most frequently used. The IAEA uses some specially designed camera systems that provide the required authentication and tamper indication. Other UMSs include the Mini-Grand Data Acquisition Module, the VXI Integrated Fuel Monitor, the Silo Entry Gamma Monitor, the Mobile Unit for Neutron Detection, the Advanced Thermohydraulic Power Monitor, and the Online Enrichment Monitor. All of these systems monitor certain attributes of an item or process to verify the presence or absence of safeguarded items or activities. Unattended monitoring systems share a set of common features, including reliability and stability, data authentication, system security, and tamper indication. Reliability is important because the systems are often left in facilities to monitor for long periods between inspector visits. Access to the systems for maintenance or troubleshooting between inspector visits would be challenging and costly. Authentication is important to provide confidence in the authenticity of the data generated. System security, which typically consists of network and computer security for the embedded systems. It includes things like virtual private networks, password management, and access control. Physical security is also important, which consists of tamper indication, including TIDs and TIEs for the device, and potentially tamper indicating conduit for any signal cables used by the system. Remote monitoring is unattended monitoring that provides remote access to data. This allows an inspector to monitor data off-site between visits and may impact the inspection time required at the facility. Off-site data access is always arranged by an agreement with the facility operator and may be limited by the sensitivity of the data collected. In summary, surveillance techniques are applied when material access is limited, inspection costs can be reduced, or continuous monitoring is needed. Surveillance systems include cameras, radiation sensors, or both for surveillance of items or processes. Surveillance is the second part of containment and surveillance, which supports continuity of knowledge for safeguarded items. If you are interested in learning more about unattended monitoring systems or tamper indicating devices, here are a couple of links that you can check out to get more information.